Recording started.
Good morning, everybody. I hope you guys are doing well today. I think the audio caught up there with us. We use it like a storage closet, but it has a window, so it's a little bit larger than like a normal closet would be. Um, but yeah, it's still not very big. But it's big enough to put my computer in for the time being and my extra monitor. Um, and I got like a little bench to sit on, so this is where I'll find myself until it's above zero outside, I guess. There is, yeah, that's a Pikachu poster if I like put it up a little bit more. Woohoo! This is like my kids' like play area, storage area type thing. So it's all decked out for the kids in here. So they get their own little kind of play room, but again, not very big. So where all their old stuff kind of goes. Oops, I hit the wrong button there. There we go. All right. So, we did get to see each other on Tuesday, which was the first day back from break. So hopefully we're kind of back into our routine now, seeing how it's Thursday. Um, the plan for today is to look at 5.05, which is the law of sines. We've only got two lessons left. One of them is on the law of sines, and the other one is on the law of cosines. I actually think you're going to like the last two lessons compared to what we've been doing and some of the other ones in Unit 5 here. So it should be a kind of nice reprieve here at the end of the semester as far as difficulty goes with what we're looking at. So that's some good news for today, is that we shouldn't really be looking at too much challenging of problems that we have to solve. I know that there were some issues with 5.04 and using some of those identities, like your half angle identities and stuff like that. Are there any major questions you want me to look at here, or do we want to save those for office hours? And should we just jump into 5.05? All right, then we're just going to proceed forward into 5.05 and look at our law of sines. So the law of sines is essentially setting up a proportion. If we can set up a proportion using some trig, we can go ahead and solve for missing pieces of a triangle. Now, the law of sines and the law of cosines is nice because we do not need right triangles anymore in order to solve them. So we can look at any type of triangle as long as we have certain information for it, and hopefully we can solve for all the missing pieces. So what the law of sines allows us to do, and it works for two, well, technically three different types of triangles. We'll talk about that third type in a moment. But we can use the law of sines if we're given angle, angle, side, or angle, side, angle. So essentially what we have to have is an angle and the side opposite that. Because we need to be able to set up a ratio to compare something else to. All right, so looking at the example below here, if I can set up a ratio using an angle and the side opposite that, I can compare that to another ratio, and I can start creating a proportion to help me solve. And if I have a proportion, then we're going to cross multiply to find the missing piece of information. All right, so in the first example here, as we look at this, we're given angle A and angle B and side A. Now the law of sines is going to work here because you have a side and an angle that's opposite it. So as long as you have a side A and an angle A, you know that you can use the law of sines because you have a full ratio that you can compare something to. All right, the first thing that I would probably do though is I notice that I'm given two angle measures, right? I got an angle A and an angle B. I would likely find the third angle first. how are we going to find that third missing angle? So think back to your geometry days, and it's probably back in your middle school, elementary geometry days. Yeah, you just subtract from 180. That's exactly what you do here. So if you're given two angles, just subtract from 180 to find that missing third angle. So what do we get here for angle C in this picture? $96. All right, that's the first missing information that you need, right? That because we need 6 pieces of information, 3 angles and 3 sides. So that gives you 6 pieces. We've got the 3 angles, so now we're going to work on finding the 3 sides. To find the 3 sides, we have to set up a proportion. So the first ratio of that proportion that we're going to set up is dealing with the angle and side A. Now, however you set up this ratio doesn't really matter. If you like using side lengths on top and then angles on bottom, that's fine. Just make sure you stay consistent with however you set this up. So we'll do sine of 36 degrees over 8 equals, and we can then either find angle B or use angle B to find side B next, or we can use angle C. Now I'm just going to start with angle B because that's what they listed originally. So I'm going to say sine of 48 degrees over side B. And I don't know what side B is, but we can find that using cross multiplication. All right, so make sure that your calculator, first of all, is set to degree mode. If it's not in degree mode, you will not be getting correct lengths for your sides here. And let's cross multiply. So to refresh your memory with that cross multiplication, we're going to do 8 times sine of 48, and then divide that by your sine of 36. And what do we get approximately for B? $10.115. Awesome. All right, now we're going to do a very similar thing to find side C. The only difference with side C is I'm still going to use this first ratio with the A's. You could go ahead and actually use a ratio with B, but you did have to round to get side B here. So I don't think that using this ratio to help you find C is the wisest move, because it's not going to give you an exact answer like if we were to use the sine of 36 over 8. We did not have to do any rounding with this information like we did for side B. So using that same ratio of sine of 36 over 8 to find side C is going to be your best bet there. But because we are looking for side C, we have to make sure that the second ratio is using angle C up in your sine. All right, now we're going to cross multiply and do the same thing here to find what side C is going to be. All right, what do we get there for side C? Of 13.536. Everybody agree with Tommy's answers there? Awesome. Yep, we should. So we're going to go ahead and box that up because we got the 3 pieces of information that we started with, and now we have the other 3 missing pieces of information. So we are good to go with this one. See, isn't that law of sines really nice compared to what we've been doing in the past? All right, if only it could stay that simple. Now, I told you that there were 3 different cases that we could use law of sines for, but there was only 2 listed here, and I said that we would talk about that third case in a moment. The third case that we can actually use a law of sines for is our ambiguous case. So we can use it for side-side angle. Now, obviously, when we were in geometry and we were learning about our triangle congruencies, we said there were no bad words in math, right? So that side-side angle, if we were to read that backwards, is not an appropriate term. So with that, we know that we have to proceed with caution. So if we're using side-side angle here, or we're given side-side angle, we can still proceed, but we've got to be careful because there's different scenarios that we can run into. So anytime we have side-side angle, we have the possibility of it not working at all. So we can get 0 results. There's 0 triangles that can be made. We can have it work just fine, like we did with the first example. So there's 1 triangle that can be made. Or we can have 2 triangles actually being made. So anytime we're dealing with side-side angle, we really have to be careful of how many triangles can we create with that given information. All right, so most of the time we're going to look to see if there are 2 triangles that can be created and not just the one that we've seen with the other. Okay, so notice that you have side-side angle here in this example below. And you do have an angle and a side that are opposite each other. So law of sines will work out here, but we just got to be a little bit careful. All right, so what do you think we're going to start off by finding? There's really only one value that we can find given this information. So there has to be only one starting point. You have to find angle B first. Yep, so we're going to go ahead and do that. First of all, we've got to set up the ratio using A. So sine of 30 over 6. Now, because we're searching for an angle measure, there's going to be a little bit extra work to this. And we'll see if we can remember what the extra piece is to find an angle measure versus a side measurement. But we still want to cross multiply here. So let's go ahead and start with that. So 7 times sine of 30 and divide by 6. What is that going to equal when I cross multiply there? A 0.583 repeating. All right, great. Now that obviously is not an angle measurement. Does anybody remember what we do to find the angle measurement now? Because right now we're sitting at sine B equals 0.583. Anybody remember what we do to get just B and get rid of the sign that's out in front? Yeah, we got to take the inverse of it. So using your calculator now, you're going to do sine inverse. So the second sine button. So second sine is going to bring up that sine to the -1 power. That's your inverse. And we're going to type in that decimal number, so that 0.583. When you do that, it's going to change it to a degree measure for you. So that's the extra little piece to find the angle measurement now. So what is that, 35.662? Any questions with how we got the 35.662 for that? All right, the nice thing is that we only need to do this proportion once because now we've got 2 angle measurements. We can go ahead and find the third just by using subtraction. So let's subtract to find angle C real quickly. What is angle C going to be in this first setup? Isaiah's got 114.338. Sounds pretty accurate to me. So we've got 5 of the 6. The only thing left now is that missing third side, which is going to be your side C. So we're going to go ahead and I'm just going to use this same proportion here so I can save myself a little bit of room on the board. So I'll start off with sine 30 over 6 because we still want to use that beginning ratio with A. But now to find side C, we've got to use angle C. So sine of 114.338 over side C. Now, because we're looking for a side length, we do not need to use the inverse here, right? It's just simply cross multiplication to help you find that. What is side C going to equal, approximately? About a 10.934? Everybody else agree with that? Yep, Isaiah seconded it. Awesome. All right, so that's one possibility. So we got all 6 pieces of information there. Because this is the ambiguous case, there might be a second possibility. So that second possibility, you cannot, no. So I'm going to, before I talk about that, Isaiah says, can we use the Pythagorean theorem? No. When do you use the Pythagorean theorem? For right triangles only. Yep, so you use the Pythagorean theorem for right triangles only. We are not dealing with the right triangles, so we want to make sure we stick with that law of sines. All right, so another question did pop up. How do we get the 114.338? To get that number, we just want to we'll double check that one. We subtract from 180, right? So 180 minus angle A, which was 30, minus angle B, which was 35.662. That should give us the 114. So we want to make sure we subtract angle A from that as well. Okay, good. All right, the other possibility, if we look down below, so we can see that first triangle that was created using 6, 7, and then this third side would be the 10.934. The other possibility might be this triangle right here. So originally we started with an acute triangle. What if this is an obtuse triangle? So instead of having angle B be 35.662, what if that was an obtuse measurement? So to find that obtuse measurement, let's subtract that value, 35.662, from 180. So go ahead, subtract that real quick, 180 minus 35.662. And what is that going to give us? A 144.338. So what happens if angle B is this large obtuse angle instead? How is our triangle going to change? Can we construct another triangle with an obtuse angle with that measurement? Well, let's see. Angle A is still going to be 30 degrees, but now angle B, we're going to say, is that obtuse measurement of 144.338. What would angle C have to be then? So using some quick subtraction from 180, it's probably going to be a very small number, but what would angle C be? A 5.62 degrees. All right, it's still possible to have an angle that's only 5.62 degrees in a triangle. So we can venture forth with these measurements for angles A, B, and C now. So we've got 2 of the 3 missing pieces already. Now we've just got to set up a ratio or a proportion to help us solve for side C. So to find side C in this scenario, we're still going to use sine of 30 over 6. But now the second ratio becomes sine of 5.62 over side C. So again, using cross multiplication pretty quickly here, what is side C going to equal in this second scenario? And it looks like it's probably going to be a much shorter distance or measurement than we had originally. A 1.175. Awesome. All right, so it is possible to get a second triangle here because we did not get any negative values. Sometimes when we go to check this out, we might get a negative value for C. And if that happens, we know that there is not a second triangle that can be created because it doesn't make sense to have a negative angle measurement, right? So sometimes we might only run into the one possibility even with the side-side angle scenario. But we always got to double check to make sure that there isn't a second possibility. In this case, there was. So with the given information that we started with, we can technically create 2 different triangles from that. And you can see the 2 different layouts right there. Again, the 2 different triangles only come into play with this ambiguous case. So that's the only time that we really got to pay attention and look for those extra scenarios is with the side-side angle. If you're given 2 angles and a side, then you don't have to worry. There's only going to be one scenario that's present. All right, let's go ahead and take a look at another example here. This time it looks like we're given a story problem. Lucky for us though, with the story problem, they set up a triangle already for the diagram. We do need to find the 3 angle measurements inside the triangle, and we have to find the 3 sides for the triangle. So they label A, B, but they give us side C, so that's good. It looks like we're going to have to do a little bit extra work to help us find angle A and angle B, but we can do that, right? How are we going to find angle A and angle B in this picture? Yeah, just subtract from 90 degrees because together these are going to make a right angle. So let's start with angle A. Isaias, that's a great question. It'll be based off of, if I go back just a slide here, hold on guys, sorry. What you subtract will be based off of that second side they give you. I believe most of the time it will be angle B because they'll give you like a side B. But if it were side C, then obviously you start with angle C, and that's what you would subtract. So you really only have one starting point with this ambiguous case, and that starting point is what you would subtract from 180 to get the second possibility. Does that make sense, using that starting point to subtract from? Okay, great. Okay. Moving forward then, let's do those subtraction pieces in this next one to find angle A and angle B. Start with angle A. What did you get for angle A? 90 minus 32 is a 58. And then angle B. of 42. Thank you. And while we're at it, actually before I get too far, angles or side C is the last information that they technically give us. So taking a look at our setup right now, we have an angle side angle. So angle side angle is not the ambiguous case. So angle side angle, not the ambiguous case. So there is only the one triangle that we have to worry about. All right. What's the first piece of missing information we should find in this triangle? Because looking at it right now, I don't think I can actually apply the law of sines because I don't have an angle and a side measurement opposite each other to create a ratio. Yeah, but we can find angle C. So let's start by finding angle C. So subtract from your 180 to help you find angle C. And what is angle C going to be? An 80 degrees. All right, and now you have enough information to apply the law of sines, right? Because you can create a ratio using side C and angle C. So we'll do sine of 80 over 10. And which side length would you like to find first? Side A or side B? A. All right, so if we're finding side A first, you have to use angle A in the numerator. So we'll do sine of 58. All right, let's do some cross multiplying here. What are we going to get for side A? Excuse me. 8.611. And then to find side B, I'll first use that same ratio again, sine 80 over 10. This time we're trying to find side B, so we've got to use angle B in our numerator, so sine of 42. I'll let you guys go ahead cross multiply one last time. And what do we get for side B? $6.795. Good, that's what I got too. All right, so we solved that triangle. Questions with that one using our law of sines? Okay. Then we've hit kind of that point where it's just practice from here on out. So it says state whether the given measurements determine if there's 0, 1, or 2 triangles. So more than likely if they're asking us if there's 0, 1, or 2, we're probably looking at the ambiguous case here, right? So side, side, angle. And that does appear to be what's happening because you're given two sides and then the angle. Yep, the ambiguous case. You got it. Where do we have to begin? So there's only one starting point with the ambiguous case. What is that starting point here? What must we find first? We must find angle B. That's the only place we can begin. So we're going to go ahead and at least set up that beginning ratio using sine A or angle A over side A. And then we're trying to find angle B. Because we're finding an angle, don't forget we're going to have to use an inverse at the end to convert our decimal into a degree. But let's cross multiply and see what decimal we're using first. So what is 7 times sine of 36? Divide by 2. a 2.057, and then we want to use the inverse of that. What happens when you type this into your calculator? You get an error. Yeah. It's invalid. It's outside the domain. If you think about it, sine needs to be between +1 and -1, right? That's what our unit circle says anyways. So 2.057 is outside of that domain. So we get an error. If you get an error, how many triangles do you think you can make given this information? None. Yeah. There are 0 triangles that you can make given this information because you ran into an error when you tried to solve for angle B. So there's one scenario, or one case or instance I should say, that you know you won't get any triangles that you can make. So you're going to run into an error in your calculator or with your calculator at some point. You're disappointed we couldn't do 2 cases? Well, let's see if there's a different one maybe. All right, 2 triangles can be formed using the given measurement, so solve both triangles. Here you go, Isaias. So it looks like we have another ambiguous case here, and this time they're saying that we can actually solve the 2 different triangles. So again, notice you have side-side angle. So that is your ambiguous case. Red flag should go up there for you. What must we start off by finding first? We got to find angle B. Yep, it's the only possibility for us. All right, as I'm setting up this proportion, you guys are probably going ahead and cross multiplying already. What do we get for angle B here? Don't forget you'll have to do the inverse in order to get that angle measurement. But what do we get for angle B? $72.74. Anybody else second that 72.74? Yes, okay. Now, another thing I want to point out that I didn't mention quite yet, use your capital letters for angles, lowercase letters for sides, right? So in case you forgot that little fact from geometry, capital letters denote your angle measurements. All right, let's go ahead and find angle C next, because that'll be needed before you can find side C. So don't forget you're given angle A already, so when you do that subtraction, don't forget to include angle A from that. What do we get angle C equaling here in this first scenario? A 43.26. Can I have somebody second the 43.26? Yep, good. Then the last thing would be to find side C. So using this same ratio with the A's, we're going to go ahead and set one up for the side and angle C. So we're going to use 43.26 for that angle measurement, and we're trying to find side C. So we'll leave that a lowercase c in the bottom. All right, cross multiply here. This time inverses are not needed because you're finding a side, not an angle. What do you get for your approximation for side C? $12.2. And Rebecca seconds that. Awesome. Okay, so that's case 1. All right, but this is the ambiguous case. there can be a second possibility. The second possibility is that angle B is an obtuse angle instead of an acute one. To get the 12.2, let's go ahead and just cross multiply and make sure here. So 16 times sine of 43.26 divided by sine of 64. So if we type that in the calculator there, that should give us the 12.1996, so 12.2 rounded. Okay, awesome. All right, so how do we start off with that second case scenario? So what if angle B is obtuse versus acute? How do you find that obtuse angle measurement? You gotta subtract from 180, yep. So 180 minus the 72.74 should give you an obtuse angle to begin with instead of an acute angle. What is that obtuse angle measurement? 107.26. Okay. If angle B is going to be that obtuse measurement of 107.26, what would angle C be? In angle C, we're expecting it to be pretty tiny. Most of the time it's going to be a really small amount here because angle B is going to be very large. Okay, before we move on any further, can we get somebody to second those answers? Okay, Isaiah's got seconded the 8.74, which means he must have used the 107.26 to begin with as well. And B is good. Awesome. All right, the only thing missing is side C. So we're going to go ahead and still use that same ratio of sine of 64 over 16 because that information for angle A and side A has not changed. But we do need to change the ratio for the angle C. So sine of 8.74 over side C here. And when we cross multiply, we should get our result. So what do we get for side C this time? Nice work, guys. 2.705 or 2.7 depending on how you're going to round there. Your homework might have you rounding to the nearest hundredth. So if that's the case, it's only 2 spots after the decimal point. I like to do to the nearest thousandth only because it's a little bit more accurate. So the 3 numbers after the decimal point is just fine. If you use just 2 numbers after it, that's fine too. So 2 or 3 numbers after the decimal point will be good. All right, any questions with that ambiguous case? And that's, again, the one that you have to watch out for the most. I do have a few more examples here before I let you go today, but I want to make sure everybody is comfortable with that ambiguous case and how we can identify it. So again, the first thing I would, if I were given a problem to try and solve with the law of sines, is looking to see if I have side-side angle. If you have 2 sides and only 1 angle, you should proceed with caution, right? There might be more than one possibility. All right, let's go ahead and give you guys some time here. Let's start with problem number 27 from the book. It says, respond in one of the following ways. So you cannot solve the problem using the law of sines. You cannot form a triangle, or yes, we can actually solve it. No problem, Isaias. All right, so this first one, with problem number 27, is this the ambiguous case? Let's just decide that first. So is that the ambiguous case? Yes, two sides and an angle. So second question, the two sides and an angle, can I actually use the law of sines? So can I set up a proportion to actually go ahead and solve it? Yes, okay. So part A is thrown out because we can use the law of sines here. So now we've got to be careful. If we can solve it, there might be more than one possibility for us to do. So first of all, let's find angle B, it looks like. So we're going to do sine of 61 over 8 equals sine of B, because we don't know angle B, so we're trying to start with, over 21. So let's cross multiply here and see what we get for angle B. .296. Now you'd have to do the inverse of that because we're trying to find an angle measurement, right? So when you do the inverse of your 2.296, you get invalid or error or a domain error, right? 2.296 is outside of the domain for sine because it's got to be between -1 and +1 to find those angle measurements. So if you get an error, can you form a triangle with those given measurements? No. No triangle is formed. Boo. Alright, although I kind of like when no triangle is formed because it saves us time. But disappointing that we don't get to use our proportions anymore. Alright, question 29. Is that the ambiguous case in question 29? Looks to be, right? Side angle. All right, so can we use the law of sines? So do they at least give us the appropriate information to try to use law of sines? Yeah, okay. So I'll start by setting that up. Again, sine of B. Looks like we're looking for angle B for starters. Let's see if we hit another dead end this time. Another invalid, an error again. All right. That must have meant that when you cross multiplied, you got a decimal larger than 1. Right? Yep. And so no triangle is formed. All right. Well, we just struck out twice in a row. All right. On to question 31. Is question 31 the ambiguous case? No. Okay. This time, it should work out for us. Can we use the law of sines? So it's not the ambiguous case, but is it set up for us to use the law of sines? It is, because you have a side and an angle that are the same, right? So we'll go ahead and at least set up our proportion. Let's see. And technically, there were two different ways you could go here. You could find angle A first. Looks like I'm on the path to find angle or side B, I should say. So it looks like we're looking for side B first, and then we'll come back and find angle A. So since it's a side, you do not need to use inverses this time around. What are we going to get there for side B? a 19.139. Awesome. And then we can't really find angle or side A without angle A. So let's do our subtraction quick to find angle A. And what do we get there? A 99. Okay, let's put the little degree marker there for that. And then to find side A, we're going to use that angle A in the numerator there. And we'll cross multiply one last time. A 28.25. Anybody second the 28.25? Yep, Isaias can. Awesome. And then Tommy can third it. Perfect. All right, it's not the ambiguous case, so there was only one setup or one possible triangle that we could form there. And there are the measurements for the three missing pieces. All right, nice job, you guys. Any questions with your law of sines? So like I said, hopefully you liked the law of sines a little bit better than using any type of identity or any type of proof. So, right, it did say triangle. Yeah, solve the triangle. Not plural there. All right, you should be good to go then for 5.05. Again, the one thing I would look out for before you even attempt any of the questions is, are you dealing with the ambiguous case? So the side-side angle. So always identify that first and then proceed from there. All right, that's all I got for you guys, so you're free to leave. Have a great rest of your day, and I'll see you guys all again next week, Tuesday. Bye, everyone.